Video number 187, graphing the cotangent function, which is the cotangent is the inverse of tangent. So what happens here is, of course, tangent is opposite over adjacent, or in other words, sine over cosine. Therefore, cotangent, COT. Here, let's write it over here. Cotangent would be simply cosine over sine, which changes things a little bit, well, quite a bit. If we were to take a look at y equals cotangent of x, well, the cotangent of 0 would be the cotangent at the point 1, 0. And obviously, cosine over sine is undefined. Now, if we did cotangent of 30 degrees, you would have root 3. Cotangent 45 is still 1, but then cotangent 60 is root 3 over 3. So the 30s and 60 reverses, okay, your undefineds and zeros inverse. So what happens is you end up with a slightly different graph. You end up with undefineds at the zeros, or in other words, at the 180s, at all the pi, you know, the 0 pi, then the 2 pi, then 3 pi, 4 pi. You end up with all the undefineds over here at these spots, rather than the tangents undefined over here at the 90s, as I called them in the other videos. So these are going to be the three main points we're going to graph: pi over 4 comma 1, pi over 2 comma 0, and 3/4 pi comma -1. Then of course we're going to know our undefineds are going to be at the zeros and the pi's. So we're going to end up with a graph that looks like this. So you're going to have undefineds at your 0 and at your 180s, pi and negative pi. And then, so now when we take a look at this, y equals cotangent 2x, we end up taking our pi over 4, pi over 2, 3 pi over 4, dividing it by 2, and that's going to give us pi over 8, pi over 4, and 3 pi over 8. There it is. Then, instead of our range being 1, 0, -1, it's 3, 0, -3. So then we would end up with, this is what, pi over 8 now, comma, 3. Alright, that's a 3. There's your 0 at pi over 4. And then 3 pi over 8 would be right here. And that would be at negative 3 in this case. Okay. There you go, put the negative here. Alright. Now, we would end up with our undefineds would actually not be at the 90s or pi's. Where would they be? They would be at pi over 2's in this case. So this would be pi over 2. So we would have 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8, 6 pi over 8, which is simply 3 pi over 4, and 7 pi over 8, and then 8 pi over 8, which is pi. Then you'd have, this is what, negative pi over 2. Then you'd have, let's see here, we're going negative pi, I'm sorry, I'm sorry, we actually did this graph where we did it like this. We called this the, this is actually the y-axis. So that would change things a little bit here. There we go, we're good. This is going to be pi over 4. So we had pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi, 6, 7, 8. Okay, good. Then back this way, we'd have negative pi over 8, negative 2 pi over 8, which is what? Negative pi over 4. Hence the zeros in the same spot, right? Then you've got, let's see here, this is negative 2 pi over 8, negative 3 pi over 8, and negative 4 pi over 8, which is negative pi over 2. So where would our undefineds be? Undefined at pi over 2, pi, 3 pi over 2, right? So basically we are going to be undefined at pi over 2 plus n times what? Multiples of pi over 2, or on the negative side as well. Of course, if you include n to be negatives, then you're in good shape. All right, so there you have it. This is cotangent, the graph cotangent, and the graph A cotangent bx as we kind of combined all of these tangent graphs together. Please do review videos 185 through 187 or 186 to double check tangent. It should be in good shape. Good times.